The following is a selected video from videomathteacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try videomathteacher.com today. Let's multiply the following matrices. Our first matrix has 2 rows and 3 columns, where the first row is 1, negative 2, 4, second row 0, negative 1, 3. We'll multiply this by our other matrix, which has 3 rows and 2 columns, where the first row is 3, 5, second row negative 2, 6, and third row 1, negative 2. To multiply these matrices, let's first determine if we can multiply these matrices together. So, describing the dimensions of our two matrices, our first matrix has 2 rows and 3 columns. So we'll describe this as a 2 by 3 matrix. Our second matrix has 3 rows and 2 columns. So we'll describe this as a 3 by 2 matrix. For us to multiply two matrices together, the interior numbers need to be the same thing, which they are. The resulting answer matrix will be a outer numbers being 2 by 2. So yes, we can multiply our matrices together since the inner numbers are the same, and our resulting matrix will be a 2 by 2 matrix. So we'll describe our answer as a 2 by 2 matrix. To determine the 4 entries in this, we'll use a process. For our first matrix, we'll refer to the rows as row 1 and row 2. In our second matrix, we'll refer to the columns as column 1 and column 2. For our result, we'll label both rows, row 1 and row 2, as well as column 1 and column 2. To find these 4 entries of our resulting matrix, we'll take the corresponding rows from our first matrix and the corresponding columns from our second matrix, multiply the entries together, and add up the results. So, for example, for our first entry here in our result, R1 and C1, we'll take the row from our first matrix and multiply it by the column of our second matrix. For each entries, we'll multiply the entries and add them all up. So row 1, column 1 will become 1 times 3 plus negative 2 times negative 2 and plus 4 times 1. Again, we took the row from our first matrix and the first column of our second matrix and multiplied those entries together and added them up. This will become our first entry in our resulting matrix for row 1, column 1. Let's find all 4 entries, simplify, and then replace that into our answer. So, for our second entry, row 1 and column 2, we'll take the first row from our first matrix and column 2 from our second matrix. That means this will be 1 times 5 plus our second numbers will be negative 2 times 6 plus our third numbers will be 4 times negative 2. Let's continue by finding our second entries. So we'll next find row 2, column 1. That means that we'll take the second row from our first matrix multiplied by the first column of our second matrix. So row 2, column 1 will be 0 times 3 plus negative 1 times negative 2 plus 3 times 1. And last, let's find row 2 and column 2. So we'll take the second row from our first matrix multiplied by the second column of our second matrix. So we'll multiply 0 times 5 plus negative 1 times 6 plus 3 times negative 2. Now that we've found these results, let's simplify to a numeric answer. So for row 1, column 1, multiplying our expressions together, 1 times 3 is 3, plus negative 2 times negative 2 is 4, plus 4 times 1 is 4. 3 plus 4 is 7, plus 4 becomes 11. So row 1, column 1 will be the result 11. For row 1, column 2, we'll get 1 times 5 is 5, plus negative 2 times 6 is negative 12, plus 4 times negative 2 is negative 8. 5 plus negative 12 becomes negative 7, and negative 7 plus negative 8 results in negative 15. So row 1, column 2 will become negative 15. Next, for row 2, column 1, 0 times 3 is 0, plus negative 1 times negative 2 is 2, plus 3 times 1 is 3. 0 plus 2 is 2, plus 3 becomes 5. So row 2, column 1 results in 5. And last, row 2, column 2 would be 0 times 5 is 0, plus negative 1 times 6 is negative 6, plus 3 times negative 2 is also negative 6. 0 plus negative 6 is negative 6, and negative 6 plus another negative 6 results in negative 12. So our result for row 2, column 2 becomes negative 12. So in summary, multiplying the matrices 1, negative 2, 4, 0, negative 1, 3 by 3, 5, negative 2, 6, 1, negative 2 results in our final matrix becoming 11, negative 15, 5, and negative 12.